Hello! Today, in this video, we're going to talk about some of the principles behind burners. And specifically, we're going to discuss the two different kinds, or sort of the two different categories, essentially, of natural gas or propane burners. And those two categories are a natural draft or venturi burner, which you can see here, or something that we have here over on our soda kiln, which is called a forced air burner. And the biggest distinction is that a forced air burner, like the name sounds, has a forced air system. This allows us to use electricity or to introduce air, essentially more oxygen, which allows us to put more fuel through the same system so that we get more heat. And you can see that clearly here. If we turn this on, you can hear that squirrel cage fan right here blasting away. And then to meet that system, we could put in a lot more gas to get more temperature. In our venturi system, we work on a natural draft because of the pressure of the gas coming through the burner, and then the air is drawn through here. So it's called an air mixer or a venturi, a natural draft, any of those terms. So the gas and the air mix in the burner tube here and then come out. And these are probably the most common. Our only forced air burner system is here on the soda kiln. And in both of our updraft and downdraft kilns over here, we have natural draft burners. Okay. A couple of good vocabulary terms to know is a primary air and secondary air. And in a venturi burner, the primary air, if you can see here, camera, is the gap right here. Now that's adjustable by spinning these. So as you can see right now, I am closing off or restricting the primary air. And in a segment coming up, we'll show you what that actually does with the flames, and we'll talk about what it does to our clay and glazes. I mentioned a secondary air. So that secondary air is air that's around the burner, basically the burner port, and we call that the secondary air. So we can control that, as you can see over here in our soda kiln, by blocking some of this off. And it's important to note that that does affect the atmosphere inside our kiln. Usually we don't do much with our secondary air. That's set by the kiln design. But it is something, if we're having trouble with the kiln, that we can play with. But really that's something that happens in soda kilns or wood kilns. You won't be doing any secondary air adjustments in any of our gas kilns. Okay, I'm going to show you our venturi burners on our gas kilns. Now, these setups are essentially the same on all of them. So this one's a good example. These are wind guards that help prevent the burners from blowing out during the firing. Most of them have these little speedy connects. Please don't lose these if you're inspecting this area. It should be relatively clean down here. And camera, if you want to come in, you can see our burner manifold. So the gas is flowing through here, and we see our venturi burners right here. What we can see right here is called our pilot ring, and I'll talk to you about how we like that and how kind of beneficial that is in early stages of firing. And then we can also see down here, these are on-off valves that turn each burner on or off individually. It's important before firing just to take a peek down here, make sure there's no leaves or debris that could catch fire, and to make sure that all the burners are on. And as you can see in this one particularly, there's some debris in the primary air. So we're going to want to hit that with a vacuum before we turn it on. In a normal firing cycle, we are not down here adjusting any of these or adjusting these. Your instructors or grad students will set them for their optimal firing kind of situation. The exception will be if we're bisque firing, and particularly if we're bisque firing large sculptural work, we're usually going to want to turn all but one or all but two of the burners off in the early stages of firing. And we'll go over that in detail when we get to bisque firing in our gas kilns. So over here we can see our control system for our updraft and downdraft gas kilns. This one in particular, we're looking at our updraft kiln, but they're all the same across all three of these kilns, which is really nice. Don't be intimidated by this. It certainly looks like a lot of mechanisms and other stuff, but there's some really basic principles, and once you understand them, you can apply it to any of these kilns. The first being, and actually is applicable to all gas kilns, gas is like water. So think of it being upstream or downstream. So to turn our gas on, we just need to follow the piping upstream. And if you'll follow me, camera, this would be our master on for a given kiln. This should never be turned off, essentially, unless it's done by an instructor or grad student. Our first on-off valve is right here. And one other thing about gas kiln valves and valves in general, when the handle is perpendicular, in almost all cases, this means that it's been turned off. If it's parallel with the pipe, that means on. I have seen some circumstances overseas where that's not the case, but the vast majority of them, perpendicular off, parallel is on. So, cut. So with all of our gas kilns, we have some really great safety features. We have them on the soda kiln as well, but they're a little less digitized. So all of our kilns are equipped with something called a thermocouple, which will sense when a flame goes out. And that's in case there's a big wind gust and it knocks out the flames. We're not just pumping gas into the kiln yard or something like that. So I talked just a moment ago about where our gas is upstream. Electricity is kind of the same. So if you'll follow me, camera, this is the first step that we're going to do in lighting our kiln. So this is the master power switch for our control box. We can walk around front, and then we can see that start to boot up here. And it's taking a particularly long time. There we go. So this is our ambient temperature, and this is a sort of alarm or max temperature. We're really not going to mess with any of this like we do in our electric kilns. We're just going to kind of look at this. And it's also important to remember that this might be a little bit off, and we really want to assess our kiln's progress by looking at the cones. This is just kind of a reference for early stages before our cones get soft. This button here will allow us to turn the kiln on, and it'll set an automatic little sparker to ignite that pilot ring that I pointed out in the other video. But we don't have any gas on, so nothing would light at that point. We could turn all the gas on, and it actually wouldn't pump any gas through the burners because of those thermocouples that I just mentioned. So the first step to lighting this, we've got our main box on. We then want to turn on the gas valve over here. Following upstream, we know the main one's on. This would be the next one to turn on. Again, no problems because we've got our thermocouple. As we follow this along, this pipe's much larger. We can notice that. This is our main burner valve right here. But we can also see that the gas makes a T here and comes down to a smaller valve here, right? And this is a smaller line, so we can deduce that this is going to give us less volume. So that's our pilot ring. The next step is to turn that pilot ring on full. Once that's on full, and again, there's no gas going out right now because we haven't bypassed those thermocouples. To ignite it, we flip this to on, and that electric sparker, camera, if you can come down here, we ought to be able to see it. You'll see it start clicking. So sometimes when we're trying to light our kiln, the automatic sparker doesn't actually ignite the pilot ring. And that's why we have these little Bic lighters here at the ready. So one of the situations that also happens when it doesn't ignite, you can follow me, camera, is that we have to come into this box and just hit the reset button. Because right now we can see that it's on alarm, and when we hit the reset, it jumps up to here, and it means that we're ready to ignite. Be sure that this has been switched to off before hitting the reset button. This is just what we have to do to get her done. So in the off chance that you can't get your kiln to ignite through the automatic lighter, we can do that with this handy dandy little Bic lighter. So we've got our gas on, we've hit the reset button in here. We'll then need to turn this to on, and when we hear the clicking, that's when we want to get our flame, our flame underneath there and lit right on the ring. So camera, if you'll follow me, we'll go ahead and light this pilot. So I've got my at the ready, and there we go. And you hear that click? That means that the thermocouple has registered the flames and it's gonna keep it on. In our glaze firings, we're gonna wanna have this at about 3/4. And in our bisque firings, we may even want to bring it down a little bit lower if the work is really wet. But I'll cover that in more detail when we have our firing video. All right, just lit your kiln. Go team.